Hey, this lesson is to use the distributive property to simplify expressions. And we're going to be doing the distributive property of multiplication first over addition. So this says that A times the sum of B and C is the same thing as the product of A and B plus the product of A and C. So um, A times this entire thing is the same thing as A times B plus the A times C. And so I'm first going to do example B the long way. So like all using all of the steps, showing every single step along the way. But our ultimate goal is to be able to do this quickly without showing work to get our simplest expression in simplest form. So long way, I'm going to take this and I'm going to write out this. So this says -2 times the quantity x plus 5 is the same thing as -2 times x plus the -2 times 5. And then I would need to do the math. I'm going to do that multiplication. -2 times x is -2x. Plus I have this -2 times 5 and I get -10. But I'm not done because this is not simplest form. I have two operation signs that can really be replaced with one. And so just like subtraction is the same as adding the opposite. Right now I have adding the opposite. I can reverse that. So a lot of you guys use like keep, change, or leave opposite for turning subtraction into addition. I can do the same thing to reverse it. So I'm going to leave this first thing the same. I'm going to change the adding to subtracting, and I change the -10 to +10. And now I have this in simplest form, this -2x minus 10. So these two expressions are equivalent. This one is simplified. But ultimately, this is one mini step in a longer problem. We don't want to have to show all of this every time. We want to be able to jump from here to here. And one of my shortcut is to kind of look at these terms separately, and I keep the sign in front of it with it. And so my shortcut is I'm going to take this -2 and I multiply it by x, and I get that -2x. And then I do this -2 times this +5, and I get -10. So then I just write -10 because I know that adding -10 is just the same thing as subtracting 10. So we're going to do the rest of these using that shortcut. I'm going to kind of draw these clouds and rainbows. So I have this 2, and I'm going to multiply that by x, and I get 2x. And then I go do 2, and I'm looking at this as a +5. So I'm keeping the sign in front of it with it, because that's part of the term. And 2 times +5 is +10, so I write +10. Here I have this 3 times 2x, and I get 6x. And then I have 3 times +4, I get +12, so +12. For this one, -3 times 2x, we get -6x. Then the -3 times +4, I get -12. And since I get -12, I'm not writing plus -12. I just know that it's the same. Adding -12 is the same thing as subtracting 12. So I got -12, I write -12. Then I have -3 times -2, and I get +6x. So I don't need to write the plus for positive, I just write 6x. And then the -3 times +4, and I get the -12. So I write -12. And then this one, is there any number to distribute? I don't see a number, but we do have this like invisible -1. This is the same thing as -1 times that quantity 2x plus 4. So we're really distributing this -1 or distributing the negative. And I want us to put a little like star sign here saying distribute negative. Okay, so if there's a negative in parentheses, in front of a parentheses, you got to distribute it through. So I have this -1 times 2x, I get -2x. This negative times +4, and I get -4. So I have this -4. Oops. Okay. Moving on to, they have a whole other distributed property for if there's subtraction in the middle. And I'm going to do it the long way first, but the shortcut is exactly the same. I'm going to do my little clouds and rainbows and keep the sign in front of it with it. But long way first, I'm going to do this H the long way. This says A times this quantity B minus C is the same thing as A times B minus A times C. So that means I'm going to have this -2 times X, and then this subtraction here, the rule keeps the subtraction there, so I'll put the subtraction there. And then they're looking at this as -2 times 5, just 5. And so then I would do the multiplication. I get -2x, and here I get minus, and -2 times 5, I get -10. But again, this is not in simplest form because I have two symbols next to each other that could really be replaced with one. So subtracting is the same as adding the opposite. So this is the same thing as adding +10. Now that's a lot of work. We don't want to have to show all that. What we're going to do is we're going to do the shortcut. We're going to do -2 times x, and that would get us the -2x. And then we'd have this -2 times the -5, and -2 times -5 is +10. So then I know to write the +10 right there. I'm going to go through these ones quickly, doing that shortcut. I have this 2 times x, I get 2x, then 2 times -5. So I'm not thinking of this as subtracting 5. I'm thinking of that as subtracting 5 is the same as adding -5. So I'm doing 2 times -5, and I get -10. Again, adding -10 is the same thing as subtracting 10. So I'm just writing subtracting 10. So then I do the 3 times 2x to get 6x. 3 times -4 is -12, so I write -12. -3 times 2x is -6x. -3 times -4 is a +12, so we're adding 12. A bunch of negatives here. -3 times -2 is going to give us +6x. -3 times -4 gets us +12, plus 12. And the last one, again, we're not going to forget, this is really -1 times the quantity 2x minus 4. So we're going to distribute that negative. And so I have this -1 times 2x is -2x. This -1 times -4 is +4, so plus 4. And I want another note that we're doing here. When I circle this, I'm circling -4. I'm not just circling the 4. We're going to keep the sign in front of the number. With it. The lights just turned off in the classroom. Okay. Couple other things. So what if the number to distribute is on the other side? Doesn't matter. So having it on this is just multiplication in these two things, and the order of multiplication doesn't matter. I can distribute backwards. But I'm going to be strategic about it because when we have simplest form, it's proper to have the variable term first and then your constant. So like this is not proper, 6 plus 4x. Would be better written as 4x plus 6. So when I do this, I'm going to do this 5 times, I'm going to do times the 4x first. I messed up there because I need to keep the sign in front of it with it. It's 5 times +4x. I'm going to get +20x. And then I have this 5 times +6, and I get +30. So I get 20x plus 30. Okay. Now, if I had gone about it a different way and did the 5 times 6 first, and I got 30 plus 20x, now this would be equivalent, but it's not in proper form. Proper grammar for math is we want the variable term first, then the constant. And since this was just adding though, I could just switch places. So I could just switch the order. But now this one, I'm going to pretend that I didn't know the proper order. And I'm going to just do this 5 times 6 first, and I get 30. And then the 5 times -4, and I get negative 20x. Now here, I can't just switch places. What I cannot do, I cannot write 20x minus 30. That would be incorrect. Okay? The sign in front of the number stays with it. We have minus 20x. That's a negative 20x. This is a positive 30. It's got a positive 30. If I was to change the subtraction to adding the opposite, it would be 30 plus negative 20x. Okay? And we can't change the order of subtraction, but if I change it to addition, then I can switch it. And so now I can switch the order here, and it turns into negative 20x plus 30. So the shortcut is, if you see the subtraction here and you need to switch places, you take the sign in front of it with it. This was a negative 20. In my answer, I still have the negative 20x. This was a positive 30. I still have a positive 30 in my answer. Okay, so you can't change the order of subtraction, but you can think of it as adding the opposite, and you can take the sign in front of it with it when you switch it. Last one, got this negative here. I'm going to do the negative 5 times the positive 4x first and get negative 20x. And then I have the negative 5x times the positive 6, and I get positive. Oops, just kidding. Negative times a positive is a negative. We're ending up with negative 30. Okay. You can also distribute to more than 2 things. So far we've only had 2 terms inside the grouping symbols, but there could be more. We could also distribute fractions. So when there's more than one thing, you just distribute to everything in that grouping symbol. So we can see here we have this A times the quantity B plus C plus D. You get A times B plus A times C plus A times D. So you just distribute to everything. And so I'm going to have lots of clouds and rainbows as I do 5 times the x squared, and I get 5x squared. I'm going to do the 5 times the negative 3x, and I get negative 15x. The 5 times the positive 4, not 12. 5 times 4 is 20. And then that's in simplest form. Now, proper notation for this, if you have varying degrees of variables like x squared and x, the highest exponent should go first, and then your constant should be last. Like, that's in proper order. If you have more than one letter, it's usually alphabetical, like XYZ or ABC. And so now I'm going to take this 2, negative 2, and distribute it to the positive 4x to get negative 8x. The negative times this whole thing. The variables are going to stay the same. Negative 2 times negative xy squared. Now I have a negative times a negative, so that's going to be positive. And I have 2 times x times y squared. Then this negative 2 times that positive y, we get negative 2y. I'm going to distribute the half. And remember, multiplying by a half is the same thing as dividing by 2. So like 1/2 times 8x is half of 8x, or 8x divided by 2, we get 4x. Half of negative 4y is negative 2y. Half of negative 5z, I can write it as, I'm going to get negative 2.5. I'm going to just write that as a fraction. I'm going to do the negative 5 halves z. Okay. So I want you guys to try these 3, and then we'll see what the answers are. For this one, you should have gotten negative x plus 3. This one is 72x minus 40. This one you should end up with negative 2x squared plus 8x minus 4.